The most confusing part of this week's lesson is the definitions of oxidizing agents and reducing agents. Oxidizing agent doesn't actually go through oxidation, it is actually reduced. What it does is it promotes oxidation of another substance. So it allows another substance to be oxidized, and it does so by gaining that other substance's electrons, taking its electrons from the other substance. A reducing agent promotes reduction. It promotes the reduction of another substance by giving up its own electrons to allow the other substance to gain those electrons. The other substance would be gaining electrons and undergoing reduction, but the reducing agent would be losing the electrons, so therefore it itself is being oxidized. Here's a graphic to help us understand. So reduced compound A, it is in its reduced state because it already has its electrons attached, is the reducing agent. So it's going to encourage another substance, substance B, to become reduced. At the same time, substance B is the oxidized compound, and it is the oxidizing agent. It is going to encourage substance A with the 2 extra electrons to become oxidized by losing its electrons. So you have to have a reducing agent and an oxidizing agent working together. So as the reducing agent A comes and meets the oxidizing agent B, the 2 electrons are transferred here, and so B picks up the 2 electrons and A loses the 2 electrons to become A with a neutral charge, and B becomes its reduced compound with the 2 extra electrons. Let's look at these 2 sets of half reactions to determine which substance is the oxidizing and which substance is the reducing agent. When we are talking about oxidizing and reducing agents, we're always talking about the reactants. So we're going to be looking at the calcium solid and the chlorine gas in our first example. And in our second example, we're going to be looking at the Zn2+ ion and the silver solid metal. So the calcium solid, looking at that first. What is it doing to the other substance? Remember, when we're talking about oxidizing and reducing agents, we are figuring out what is happening to the other substance. So calcium solid is causing the chlorine to gain 2 electrons because the electrons are on the reactant side. So in the chlorine reaction, it is a gain of electrons and it's undergoing reduction. So calcium metal must be a reducing agent. Now, what is the chlorine doing to the calcium? Now, chlorine gas is causing the calcium to go from a 0 charge to a 2+ charge. In order for that to happen, the calcium must be losing electrons and it must be undergoing oxidation. So chlorine is causing calcium to be oxidized, so chlorine must be the oxidizing agent. A second way we can look at this is we can determine which type of half reaction each one of these is. So calcium is going from 0 to 2+, and therefore it must be losing electrons and undergoing oxidation. Now that means calcium metal is not the oxidizing agent because itself is being oxidized. Calcium metal must be the reducing agent. Chlorine is going from a 0 charge to a 2- charge, so it is gaining electrons and undergoing reduction. Itself is undergoing reduction, so it can't be the reducing agent. It must be the oxidizing agent. 2 ways to look at it. Try this one on your own. Pause the video and see if you can figure out which one is the oxidizing agent and which one is the reducing agent. So zinc 2+ is causing silver to go from a 0 charge to a 1+ charge. For this to happen, silver must be losing 1 electron. So silver is undergoing oxidation. Therefore, zinc 2+ must be the oxidizing agent. Looking at silver in the other method, we can figure out what type of half reaction silver is undergoing. Silver is going from a 0 to a 1+ charge. 0 to 1+. It must be losing 1 negative charge for that to happen, losing 1 electron. So it must be itself undergoing oxidation. It can therefore not be the oxidizing agent, and it must be the reducing agent. So the reducing agent would be silver, and the oxidizing agent would be zinc. Here's your homework for this week's lesson.